Hey guys, in this video I'm going to run you through all the solutions for the AQA 2024 A-Level Maths Paper 2. Every question is going to be timestamped so you can easily jump to a question or rewatch it if you need to. Hope you find this helpful. Okay, so here we are at the front of the paper. Question 1 says, line L has equation 5y equals 4x plus 6. Can we find the gradient of a line parallel to line L? So basically just asking the gradient of the line we have. To get the gradient, we need to make sure we write it in this form, y equals mx plus c. So if we were to do that, we'd have y equals 4/5 of x plus 6/5. So the gradient then is 4/5, so it's the third option. Then question 2 says, one of the equations below is true for all values of x. Identify the correct equation. So basically it must be an identity if it's true no matter what the value of x is. You just have to recall what your trig identities are. So the trig identity that you learn is cos squared x plus sine squared x equals 1. And we can rearrange that in any way we like. So one possible rearrangement would be the third option. So that would be the answer. Moving on to question 3. It says it is given that 3 log base a of x equals log base a of 72 minus 2 log base a of 3. Solve the equation to find the value of x. So whenever you get a logarithmic equation like this, guys, you're going to want to just combine all the logs and unlog it once you've combined it all down to one log. So to combine it all down to one log, we're first going to have to deal with these coefficients here. So we can use the power rule to deal with that. So bring it in as a power instead. So rewriting the equation doing that, we'd have log base a of x cubed equals log base a of 72. And it would be minus log base a of 3 squared, but that's just 9, so we'll write log base a of 9. And then we can combine the two logs on the right-hand side with the subtraction rule, which means we divide the insides of the logs. So doing that, we have log base a of x cubed equals log base a of 72 over 9. That's just 8. So log base a of 8. Then what we can notice is we've got log base a of something equals log base a of something. So if they're equal, the things inside these logarithms must be the same. So in other words, x cubed must equal 8. And that means the only option for x would be 2. Moving on to question 4, it says the curve C has equation y equals 8 sine x. And it says curve C is transformed onto curve C1 by a translation of vector 0, 4. So shifting it up by 4. So we need to remember our graph transformations. A translation vertically corresponds to f of x plus a. So for us, that's going to be just 8y equals 8 sine x plus 4. Then part B says curve C is transformed onto curve C2 by a stretch of scale factor 4 in the y direction. So a stretch in the y is notated like this. So a times f of x. So we would have y equals 4 times 8 sine of x. 8 sine of x. Which is just 32 sine of x. Then the last part C, curve C is transformed onto curve C3 by a stretch of scale factor 2 in the x direction. So what we have to remember with this, well, first off, stretches in the x direction are written like this. Sorry, a times x. But they actually do the inverse of whatever number's there. So if I want to stretch by factor 2, that means I actually need to divide by 2 on the x. So it would be f of x over 2, what I want. So that means I would have y equals 8 sine of x over 2. Moving on to question 5, it says a student suggests that for any positive integer n, the value of the expression 4n squared plus 3 is always a prime number. Prove that the student statement is false by finding a counterexample. So to find a counterexample, we just have to find one example where it's not true. So it has to be a positive integer though. So let's just run a few positive integers until we find one that doesn't give us a prime. So for n equals 1, we get 4 times 1 squared plus 3. That's 7. That is prime, so haven't found one yet. For n equals 2, we have 4 times 2 squared plus 3. That would be 16 plus 3 is 19. That's also prime. So keep going. N equals 3, we'd have 4 times 3 squared plus 3. So that is, well, 3 squared is 9. Times that by 4, we get 36. And then plus 3 is 39. That's not prime. That is 13 times 3. So it has factors other than itself and 1. So it's not prime. And therefore, the student's claim is false. Okay, moving on to question 6, it says, in the expansion of 3 plus ax to the n, where a and n are integers, the coefficient of x squared is 4,860. Show that 3 to the n a squared times n minus 1 equals 87,480. Okay, well, the information we've got is about the coefficient of x squared. So if we're going to do that, we're going to need to write out the we're going to write out the coefficient of x squared that we would get from this. So if we remember, the general term in a plus b to the n is a to the n minus r, n choose r, times a to the n minus r, then b to the r. So we want to have r be 2 because we want the ax squared term. So we'll be doing n choose 2 times 3 to the power of n minus 2. And then it will be ax all squared. So we need to simplify this down. First off, if we write out the formula for the choose function, that would be n factorial over n minus 2 factorial, times 3 to the n minus 2. And then this would be a squared x squared over here. And then if we think about this, the n factorial over n minus 2 factorial, a lot of things are going to cancel in that, right? So if we have n factorial, that's n times n minus 1 times n minus 2, so on. And then n minus 2 factorial is going to be n minus 2 times n minus 3, and so on. So all this, everything below n minus 2, including n minus 2, cancels, and we're just left with n times n minus 1. So if we look at this coefficient, then what are we going to have left? We'd have n times n minus 1 over 2 factorial. That's just 2 times 1, so just 2. Then 3 to the n minus 2 times a squared. And they say that coefficient of x squared is 4,860. So first off, we can get rid of this 2 here. And also we'll notice that they have 3 to the n, not 3 to the n minus 2 in their example. And if we think about what that really is, 3 to the n minus 2, we could write that as 3 to the n divided by 3 squared. So if I multiply both sides by 3 squared, or 9, I'm going to get rid of that minus 2 in the power there. And then it's also multiplied by 2. So 2 times the 9 as well, that's times 18. So on the left, we'd be left with n minus 1 times 3 to the n times a squared, and then be 4,860 times, what did I say, times 18, which does give us the 87,480 they asked for. Okay, then it says the constant term in the expansion is 729. The coefficient of x in the expansion is negative. So that's two pieces of information. The 729, that will just come from this, the first term, which would just be 3 all to the n. So we know that 3 to the n must be 729. And then if you check, that will come out as let's just do it. So 3 to the 6, if we check that, is it 729? Yes, it is. So that means n is 6. If you wanted to solve it, you could use a logarithm, right? You could do log base 3 of 729 to check as well. Good. Then it says find the value of a. So we can go back to here to find the value of a, but let's note we also haven't used this piece of information yet, so maybe we're going to probably exclude a positive solution, I'm going to guess, based on that. So if we write this out again, but including our n value, so we know 6 times 6 minus 1 times 3 to the 6 a squared times a squared equals our 87,480. If we simplify that up, so we have 6 times 5 times 3 to the 6. That gives us 21,870. So we have 21,870 a squared equals 87,480. So then a squared would be 87,480 all over 21,870. So let's compute that. 87,480 divided by the last number we just had is 4. So if a squared is 4, that would say a squared is, a is plus or minus 2. But they said that the coefficient of x in the expansion is negative. So actually, yeah, we actually have a think about what's going to happen with the coefficient of x. So the coefficient of x would be 6, choose 1. Then it would be 3 to the power of 5, and then ax to the 1. So if that's going to be positive, we need a to be greater than 0. We need a to be positive. So if a is greater than 0, if this is going to be positive, then we actually need a to just be the 2 and not the minus 2. Moving on to question 7. It says point A has coordinates 4, 1, and point B has coordinates minus 8, 5. Find the equation of the perpendicular bisector. So if we want the bisector, we need the midpoint. So we can find the midpoint by just averaging the coordinates of both points. That would be 4 plus minus 8 all over 2, and then 1 plus 5 all over 2. Which is just 4 plus minus 8 is minus 4, divide that by 2 is minus 2. 1 plus 5 is 6, over 2 is 3. And then if we're going to have the perpendicular bisector, we need to find first the gradient of AB, and then we can do the negative reciprocal to get the gradient of our perpendicular. So let's do gradient of AB first. Actually, I'm going to do B to A as we running along the x-axis is B first. Doesn't really make a difference though. Doesn't matter. Going from B to A, we go down by 4, because, well, let's just write it out. 5 minus 1 over minus 8. Sorry, I'm doing this the wrong way around. Let me write it out again, sorry. We're going minus 1, sorry, 1 minus 5, because we're going down by 4, and then it's going to be 4 minus 8, minus 8, excuse me, because we're going to be going along by 12. That would be minus 4 over 12. Or if we simplify that, that's minus a third. That means the gradient of our perpendicular is going to be the negative reciprocal, so just 3. So now we have enough to find the equation, because we know it's going to be y equals 3x plus c. And we know that it must pass through minus 2, 3 if it's going to be a bisector, so we can plug that point in. We'd have 3 equals 3 times minus 2 plus c. That is going to be, c would be 3 and then plus 6, so 9. So our final answer would be y equals 3x plus 9. Then part B says, a circle passes through the points AB. A diameter of the circle lies along the x-axis. Find the equation of the circle. Okay, so that's kind of strange information. So to visualize it, I always recommend drawing it. So let's first plot our points in some kind of way. We have the point 4, 1. Let's say 4, 1 lives here. So, and let's say the x-axis is here. And then we've got the point minus 8, 5. That's going to be over here somewhere. And it says the x-axis is a diameter, so it's going to have to look something like this. Oops. That's minus 8, 5. I have to look something like that, where that's a diameter. So we know that what that tells us is the center is on the x-axis. So what we can do, and we've had a bit of a hint actually from the previous bit, they made us find the perpendicular bisector of AB. And there's a circle theorem for the perpendicular bisector of a chord, right? That's point B, that's point A. And we know the perpendicular bisector of a chord must go through the center. So my diagram's not perfect in terms of the scale, but we know our perpendicular bisector, which is y equals 3x plus 9, must go through the center. So we can find the center really easily just by setting y equal to 0 then, because that's what, if this is the line y equals 0, if we're along the x-axis, right? So if we do that, if y equals 0, then we'd have 0 equals 3x plus 9. That would give us x equals minus 3. And if x is minus 3, then we know our point is minus 3, 0 for the center. And if we want an equation for the circle, we need to have the center and the radius. So to find the center, the radius, we can just do the distance from our point to our center we found to any of the points on the circle. So I'm going to pick the point A. We've got minus 3, 0, and then let's just write out point A again. That was 4, 1. So if we do the distance, we know going from the center to 4, 1, it is going to go along by 7 and go up by 1. And then if we do Pythagoras to find the radius, it would be the square root of 7 squared plus 1 squared. That's the square root of 50. So plugging into our circle equation, which is of this form, right? X minus a squared plus y minus b squared equals r squared. We would have it would be x plus 3 to give us the minus 3 center, and then just y squared on its own, because b would be 0, and then 50 for r squared. Okay, moving on to question 8. It says, prove that the graph of the curve with equation y equals x cubed plus 15x minus 18 over x has no stationary points. Well, to find stationary points, we would solve for when dy by dx equals 0. So basically, we're going to have to prove that that equation for this curve has no solutions if we're going to prove it has no stationary points. So first we're going to need to differentiate. Let's start by just writing everything as a power of x. So we'd have x cubed plus 15x, and it would be minus 18x to the minus 1. Then dy by dx would be 3x squared plus 15, and then plus 18x to the minus 2. And we want to solve with that 0. So that looks kind of horrible right now. Let's just appreciate like why I'm thinking the way I'm about to. Let's turn it back into a fraction. So generally speaking, we don't really like looking at fractions when we've got our variable we want to solve in the denominator. So let's multiply up by x squared to get rid of that problem. We multiply both sides by x squared. We have 3x to the 4 plus 15x squared plus 18. And now this is actually something more familiar. It's a quadratic form. So it's a quadratic in a sense because this term is the square of this term. Yeah? So we can think of it as a quadratic. If it helps, I'll make this little substitution. If we say u is x squared, this equation would become 3u squared plus 15u plus 18. And then, well, we can, there's a chance there might actually be solutions for u, but then there's no solutions for x. So let's just use our quadratic solver to quickly check if there are any solutions. And if there aren't, we'll prove why, or we'll show why. So if we use the quadratic solver, we go to equation, polynomial, quadratic. So our little quadratic in disguise is 3, coefficients of 3, 15, and 18. So that actually does have solutions, this quadratic in disguise, but they're for u. So that gives us u is minus 2 or minus 3. But then if we relay that back to x squared, so that would mean x squared equals minus 2 or minus 3. We can't actually square root a negative number, right? There's no real numbers that satisfy where we square it, the property of squaring it and getting a negative. So no solutions for x. Which proves that this doesn't have stationary points because there's no solutions for our equation for where the derivative equals 0, which is what stationary points must satisfy. Okay, moving on now to question 9. We've got a curve of an equation for a curve, and it says the curve intersects the line y equals 2 at the points 1, 2, and 9, 2. So in other words, like if it intersects, those points also lie on the curve. So we're free to plug in those points into the curve. And then we could find values of a and b, which is what it asks for in 9a. So if we plug the points into the curve, we would have 2 equals 1 minus a root 1 plus b. And if we just simplify that quickly, that would give us b minus a equals 1. And plugging the other point in, we would have 2 equals 9 minus a root 9 plus b. So that would leave us with b minus 3a equals minus 7. And now we have two equations with two variables, so we can solve simultaneously. What I'm going to do is rearrange this one for b. So b is a plus 1 then. So we plug that into the second one, we'd have a plus 1 minus 3a equals minus 7. Solving for a, we would get 2a equals, we'd get 2a equals 8, means a is 4, which is what they asked for, and then we know b is just a plus 1, 4 plus 1 is 5. Okay, next up for part B, it says on the diagram, the region enclosed between the curve and the line y equals 2 is shaded. Show that the area of this shaded region is 16/3. So the shaded region they've included here is curved, so we know we're going to need an integral. Whenever I'm going to need an integral, I'll always draw boundaries from the left and rightmost sides down to the x-axis. So doing that, we could see we could get this area beneath the shaded area with an integral of the curve from 1 to 9. And then if we think, okay, well, if we look at this rectangle, which has a height of 2 and a base of 8, if we take the area of that and then subtract the area we could find from the integral for the curve for the area underneath the shaded area, we could get the shaded area. So let's find the area of the rectangle first. That's very simple. That's just 8 times 2 is 16. And then for the area underneath the curve, we know we're going to be doing the integral from 1 to 9 of our curve here is x minus a root x. A was 4, so x minus 4 root x, and then plus b, which was 5. Then to do this integral, we're going to turn the root x into a power of x. That'll be the integral from 1 to 9 of x minus 4x to the half plus 5. And then integrating that, it would be a half of x squared, then 4 divided by 3 over 2. What's that? 4 over 1.5. That's 8 over 3. So minus 8 over 3 x to the 3 over 2 plus 5x. And then we to run our limits. Let's just write out the limit step where we do a half of 9 squared minus 8 over 3 times 9 to the 3 over 2 plus 5 times 9. That would be the top limit, and then subtracting the bottom limit, which would be a half of 1 squared minus 8 over 3 times 1 to the power of 3 over 2 plus 5 times 1. And then I'm just going to use the calculator to evaluate both those limits. So first limit is 0.5 times 9 all squared minus 8 over 3 times by 9 to the power of 3 over 2, and then plus 5 times 9, which is 27 over 2. Take away the bottom limit, which if I just go back to this calculation and replace all the 9s with 1s, a 1 there, oops, a 1 there, a 1 here. That gives us 17 over 6. Oops. 17 over 6. So then 27 over 2 minus our answer of the 17 over 6 is 32 over 3. And then remember the final answer, so the shaded area was the rectangle, which was 16, minus our 32 over 3. So if we now just do 16 minus our answer again, the 32/3. We do get 16/3 that they asked for. Oh, sorry, the workings wasn't showing there. 16/3 is at the bottom there. Okay, moving on now to question 10. It says, a singer has a social media account with a number of followers. The singer releases a new song and the number of followers grows exponentially. And then they've got the formula. Then they give us some information about some pairs of points that they've actually plotted here. But notice they plotted it on logarithmic axes. So whenever we do this, we're going to be thinking about comparing this, like the logged form of this equation, to y equals mx plus c, and then we can interpret how the gradient and y-intercept relate back to the original model, the exponential model. So let's go to part 1. So yeah, they're asking to write this in this logarithmic form. So if we start from the equation they gave us, that was f equals ae to the kt. So first off, if we want natural log of f, we're going to need to log both sides. So natural log of f would be natural log of a e to the kt. If we split up that right-hand side log now, because it's multiplying on the inside, we can write that as addition. That would be the natural log of e to the kt plus the natural log of a. And then we know that the natural log of an exponential, that those two operations are inverses of each other, so they cancel each other out. We are left with natural log of f equals kt plus natural log of a, which is what they asked for, just written in a different order. Then it says, using the graph, estimate the value of the constant a and the value of constant k. So this is the point where we're going to, if like our graph is a straight line, so we can think, well, how does this relate to y equals mx plus c? So our y-axis is the natural log of f. Our horizontal axis is t. So that means the gradient must be k, and our plus c, the y-intercept, must be the natural log of a. So we can just go and look at the graph of the gradient and the y-intercept, or the vertical intercept, I should say, and get k in the natural log of a. So first off, the gradient from our graph, let's actually take the 2 points they plotted it for. That would be a good idea, wouldn't it? So 5 days after the song is released, 9,200 followers, but we have to be careful because we have to look at the natural log of those values, right? So natural log of 9,200 minus natural log of 2,050 would be our rise. And then that's over the course of, well, it's from 2 days to 5 days. So that's a different, like, if we look at the run, we can see that's a run of 3 days. So our gradient is the natural log of 9,200. Let's just plug that in the calculator. So shift there, get the natural log, good. 9,200 minus natural log of 2,050 all over 3 gives us that. So the gradient, which we said is k, is 0.500. So k equals 0.5. And then the y-intercept is the plus c, or the natural log of a. So natural log of a, if we go back and read off the graph, is this value here, which is 6.6. So natural log of a is 6.6, meaning that a would equal e to the power of 6.6. Then it says, show that df by dt is k times f. So if we go back to our original model, which was just f equals ae to the kt. If we differentiate that, we just have to bring down the k. So that would be df by dt equals a times k e to the kt, or we can think of that as a to the kt times k. Well, that's just the f, isn't it? That's the original f again. So that's just k times f, like we asked for. Then it says, using the model, estimate the rate at which the number of followers is increasing 5 days after the song is released. So the rate is the derivative, the rate of change with respect to time. So what we need to do is plug in to our derivative we have here, which is k times f. So df by dt is k, which we got the value of k to be 1/2, so 0.5, times the number of followers on that day we were asked for. So after 5 days, it was 9,200. So 0.5 times the 9,200 is 4,600. And then let's give some units. So that's in followers was what f was measured in. And then t was measured in time, is time for days. So followers per day after 5 days. Then it says the singer claims that 30 days after the song is released, the account will have more than 1 billion followers. So I would say that's a bold claim. Right now it's following, well, we've only got 2 data points, right? And 5, what do they ask for? After 30 days, that would be extrapolating well beyond the very limited data set we have. So I'd say that's a bad claim to make. It's extrapolating well beyond the range of data she has. Sorry, bad claim. Extrapolating far beyond data set. Okay, that's the end of that question. Okay, moving on to the statistics part of the paper. First question 11, we have a scatter plot, and it says one of the adults is an outlier. So we can quite clearly see that this data point is an outlier, and that is around 6 on the x and over 140 on the y. So that's this point here, isn't it? Point B. So we'll circle point B as the outlier. Then it says, which one of the following is not a measure of spread? Circle your answer. Well, that's just the median. The median's a measure of average. All the others are a measure of the spread of the data. Okay, moving on to question 13. It says the head teacher of a school wishes to collect the opinions of the students on a new timetable structure. To do this, they collect a random sample of size 50 stratified by year group. So that means our sample needs to be have proportional representation, and the population is 720 students, and then we've got the breakdown of the year groups. So we need the proportion of students in each year group in the population to be the same proportion in our sample. So if we do the year 10 students first, for year 10, the proportion is 200 of the 720, and I want that proportion of 50 to get the number of students in our sample of year 10s. So doing that in the calculator, that's 200 over 720 times 50. And then we can't have non-integer values because it needs a sample of people. So we're going to round to the nearest integer on each of these. So that would be 14. And then we'll go back and do the same calculations. Let's just write the calculations out quickly. So for year 11, it's going to be 240 over 720 times 50. For year 12, it's going to be 150 over 720 times 50, and year 13 is going to be 130 over 720 times 50. So if we just alter our calculation for each of those, the next one's 240. So nearest integer is going to be 17. Then we can go back and do 150. That's going to be 10.4. So this one's rounding down. That's 10. And then the last one is 130. So that's 9. And then we can see those do actually add up to 50. So we're that makes sense. State one advantage of using a stratified random sample. So a stratified random sample is a better representation of your population because you have the same because you have proportional representation. So better representation of the population as it proportionally represents each group in the population. Moving on now to question 14. It says the discrete random variables x and y can be modeled by the distributions given there. It is given that the mean of x is equal to the variance of y. So first off, we need to know the mean and the variance of a binomial. So the mean of a binomial is NP, and the variance is NP 1 minus P. So the mean of x would just be 40p, and we know that's equal to the variance of the y distribution. So that would be 25 times 0.6 times 0.4. So p then is just 25 times 0.6 times 0.4 all over 40. If you plot that in the calculator, that's 25 times 0.6 times 0.4 all over 40, which is 3 on 20. Well, let's write it as a decimal, actually. As a decimal, that's 0.15. Good. Then it says find the probability y equals 17. So that's just a question for the probability distribution. So we can use our distribution function on our calculator. So we're after a particular value. So that's the probability distribution, not the cumulative. And then we'll type in 17. Then we use our n and p from the y distribution. So that's 25 and 0.6. That gives us a probability of 0.119, or to 3 significant figures, it would be 0.120. Okay, that's the end of the question. Moving on to question 15. It says the number of flowers which grow on a certain type of plant can be modeled by the discrete random variable x. The probability distribution is given in that table. Can we find the value of p? Okay, so for any probability distribution, we know the sum of all options must come to 1. So that must mean that 0.03 plus 0.15 plus 0.22 plus 0.31 plus 0.09 plus the p equals 1. So if we just do, if we go to our calculator and just take away all those values from 1, so 1 minus 0.03 minus 0.15 minus 0.22 minus 0.31 minus 0.09, we get a fifth. or 0.2. Then it says 2 plants of this type are randomly selected from a large batch received from a local garden center. Find the probability that 2 plants will produce a total of 3 flowers. Okay, so large batch means basically if we pick one out of the batch, it wouldn't. Hang on, no, sorry. X is the number of flowers which grow on a certain type of plant. So we don't really need that, to be honest. We're going to assume that the plants are independent, so we can just think about, well, what are all the options we can get a total of 3 flowers to happen? So we could have the options be, well, 0 and then 3, or 3 and then 0. We could have the options be 1 and 2, or 2 and 1. Now, if you think about it, like, both of those will have the same calculation, so that would be 2 lots of the probability x equals 0 times the probability x equals 3 which comes out to be 2 times 0.03 times 0.31, which is 0.0186 from those 2 options, and then the second 2 options would be 2 lots of probability x equals 1 times probability x equals 2. Again, it's times 2 because there's 2 ways we can get 1 and then 2. It could be first, second, or second, first. So let's go back and change this calculation. So now it's going to be 2 lots of 1, or 0.15, and then 2, and then times 0.22. As a decimal, that is 0.066. So the total probability so that would be like the probability x1 plus x2, like the 2 plants we get, equals 3, is just those 2 added up. So 0.066 plus the 0.186 we got earlier. 0.0186 earlier. Which is 0.0846. Then it says state one assumption necessary for the calculation in part B to be valid. So by me multiplying these values together, we've assumed statistical independence. So the 2 are the plants grown, sorry, the flowers grown on each plant, or number of flowers grown on each plant are independent events. Comment on whether in reality this assumption is likely to be valid. So, probably not, right? They're flowers of the same species, so they're gonna be more like they're genetically similar, right? And also the conditions that would probably promote how many flowers they produce are common between them. You know, like sunlight, like if they're all in the same place, these plants, and they get the same amount of water, the same amount of sunlight, the parameters that would tell them how many flowers they get are going to be the same. So they're not independent, I would say. Not likely to be independent. I don't actually say to explain our comment, to be honest, so we can just leave it as just the comment and just say it's not likely that they are independent. Sorry guys, just a quick correction. I think I kind of misinterpreted what was read there. So actually I do think we need to state a reason why they're not independent. So let's go with the one that they're likely, if they're grown in the same conditions, they're likely to produce similar amounts of flowers. More likely, we'll say, to produce similar amounts of flowers. Moving on to question 16, it says we've got an investigation into the hydrocarbon emissions X in grams per kilometer from cars in the large data set was carried out. The results are summarized below. So we've got the summary statistics, and it just says first, can we find the mean from the summary statistics? So the mean, let's say x bar, is the sum of x over n. That's 128.657 over n, which is 2,405. So calculating that is 128.657 all over 2,405, which to three significant figures is 0.0535. And that would be grams per kilometer. Then it says find the standard deviation. So the standard deviation is the square root of the sum of x squared over n minus our mean squared. So first off, let's find the sum of x squared over n. That is 8.701 707 all over 2,405. And then we can take away our 0.0535 squared. And then we need to square root that. So square rooting our answer, we get 0.0275 to three significant figures. That's also in grams per kilometer. Then it says the large data set is a sample taken from the entire UK Department for Transport Stock Vehicle Database. It is claimed that the values in Part A, Part 1 and A, Part 2 obtained from the large data set should be reliable estimates for the mean standard deviation of hydrocarbon emissions for the entire UK Department for Transport Stock Vehicle Database. State with a reason whether this claim is to be correct. So it's not going to be correct because our large data set, if we know, doesn't include all the models of car. So not correct, or not likely to be correct, we should say. The chance it could be. Then moving on to the next part, it says state one type of emission where more than 80% of the data is known for cars in the UK Department for Transport Stock Vehicle Database. So the most common things that we track CO2 emissions, right? So that would be a definite one that's going to be in the database. Moving on to the last question, it says the proportion of vegans in a city is thought to be 8%. The owner of an organic food cafe in the city believes that the proportion of their customers who are vegan is greater than 8%. To test this belief, a random sample of 50 customers at the cafe were interviewed, and it was found 7 of them were vegan. Investigate the 5% at the 5% level whether the sample supports the owner's belief. So that's a hypothesis test. So first we need to define a random variable. Let's say x is the number of vegans. If we're assuming that 8%, we're going to test against that. Our distribution would be a binomial, and then he's taking a sample of 50, and the proportion of that, the probability of anyone being a vegan, assuming 8%, would be 0.08. And then our null hypothesis is what we're using in our distribution for our calculation, so that's p equals 0.08. And then the alternate hypothesis is the belief, which is he thinks the proportion is greater than 8%, so greater than 0.08. And we're doing this at a 5% significance level. So that's a one-tailed test, 5%. Let's use our calculator to go and find... Well, we can just test his statistic, actually. We don't need to find the critical region. So we need to find the probability x is greater than or equal to 7. That's 1 minus the probability x is less than or equal to 6. If we go to our distributions and use the cumulative distribution now, because I want less than or equal to 6, we'll type in 6. Then the sample size is 50. And then we're using 0.08 for our p-value. That is 1 minus 0.8981. So there is a 0.1019 chance of getting 7 or more customers. So that's reasonably likely. In other words, there's no evidence to reject the null hypothesis, or there's no evidence to support the claim. So no evidence to support owner's belief. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.